Hello friends, this is the 8th video in the CSES sorting and searching video series. In this video, we will be solving the problem number 8, which is maximum subarray sum. The problem statement is, given an array of n integers, your task is to find the maximum sum of values in a contiguous non-empty subarray. In input, the first input line has an integer n, the size of the array. The second line has n integers, x1, x2, xn, the array values. In output, we have to print one integer, the maximum subarray sum. Constraints are n is greater than or equals to 1 and lesser than or equals to 2 into 10 raised to power 5. Then xi is greater than or equals to minus 10 raised to power 9 and lesser than or equals to 10 raised to power 9. Then we are given a sample case. First, let's understand what the problem statement is. In this problem, we are told that we are given an integer n, which is the size of our array. Then we are given n different integers, which are our elements of array. We have to take these elements and then find the maximum sum for a contiguous non-empty subarray. That means we have to take a subarray from our array which has maximum sum than any other subarray from this array. Constraints are n is greater than or equals to 1 but lesser than or equals to 2 into 10 raised to power 5. That means our solution should be, in worst case, its time complexity should be n log n. It shouldn't go beyond that. Then our elements are starting from negative 10 raised to power 9 and they can go up till 10 raised to power 9. Now let's see the sample case. So this is our sample case. First, let's see how we will get solution for this particular test case. So if we start from 3 and go till 3, our answer would be 3 minus 2 plus 5 plus 3. The sum of our subarray would be this. Now let's check what is this resulting into. So this sum is resulting into 9. We are getting 9 from these 4 elements. 3 minus 2 is 1, then 1 plus 5 is 6 and 6 plus 3 is 9. If you will see other subarrays, you can't get any other subarray which is beyond 9, which gives us sum greater than 9. If you will consider this minus 1, adding this will create a subarray with sum 8 because it is negating 1, so it will decrease our sum by 1. If we will add these 3 elements, then our sum would be negated by 5 and incremented by 4, which will on net basis it will result into a negation of 1, which will also result into the sum 8. So we cannot get sum better than this. Now let's see how we will approach this problem. So what we could do is, we can start from the first element and check that all the subarrays possible till this element, what are the various sums we can get, what are from all the subarrays, and then we can record our best sum till here. Let's call this variable max sum. So our max sum would be for first element minus 1, because there is only one possible subarray till minus 1, till first element. We can only create one subarray with this one element, so our max sum would be minus 1 initially. Then we will move to the second element. Now we will check all the subarrays possible till this element, which of these subarrays will give us the best sum, and then we will check that is this sum better than the previous max sum. If it's better, then we will update our max sum. So now let's see what are the various subarrays we can get at this element. So either we can create a subarray with this element individually, or we can consider this element consider adding this element to the best subarray till first index. Now best subarray till first index is giving us the sum minus 1, but if we add this 3 to it, we will get 2. If we consider this subarray, this subarray will give us the sum 2 because 3 minus 1 is 2, and if we consider this subarray, the sum would be 3. So the better of both is, the best one is 3, so we will consider 3. So the best sum till second element is 3. Now we will update our max sum since we are getting a sum better than the previous one. So we will update our max sum. Then we will move to the next element. Now there are multiple possible subarrays for a particular element, but we won't be considering all the subarrays. We would be considering only those two subarrays, either one of which is including this element and one which includes this element plus the best subarray till the previous element, because till previous element there might be various subarrays, but we will consider only that one which is giving us the best sum. Now if we consider this element individually, it will provide us the sum -2, but if we add it to the best subarray till second element, then it will provide us the sum now there might be small possible subarrays, but we will consider only the best subarray till previous element. Now the best subarray till previous element is this one with sum 3, so we will add our 2 to this particular subarray, or -2 to this particular subarray. So this subarray now, which is formed with best subarray till first element plus adding this element, will result into the sum 1, or else we can consider a subarray which is including only this element, that will provide us sum -2. So the best sum is 1 from the two sums. The best one is 1, so we will consider 1. Now we don't need to update our max sum since the resulting sum is not greater than the max sum which we have till now. Then for 5 there are two possibilities. Either we can add it with the best subarray till previous element, or we can consider it individually. Now if we add our 5 with the best subarray sum till previous elements, now the best subarray sum till previous element was 3 minus 2. So if we add 5 to 3 minus 2, that will result into 1 plus 5, that is 6. And if we consider 5 individually, that would be just 5. So it would be better to add the fourth element, or say third element if we consider zero based indexing, to the best subarray sum till second index instead of considering it individually. So it will result into maximum sum of 6. So we will update that sum because it's better than the previous maximum sum. Then after that, what we would do, we will move to the next element. Now for next element also, we can consider both the cases, and the better case is, instead of considering sum 3, we can add it with the best subarray sum till index 3, which will result into 6 plus 3, that is 9, because best subarray sum till index 3 is 6 and the element at index 4 is 3, so it will result into sum 9, and this way we will get 9. And then if we will proceed so on, we can get either -5 or 9 minus 5. So the best is 9 minus 5, which is 4. Then we can get, now we don't need to update max sum, then we can get either 2 or 4 plus 2, that is 6. We don't need to update max sum. Then we can get either 2 or 6 plus 2, which is 8. We don't need to update max sum again. Now let's try to code this problem. Firstly, we will take our integer n, then we will create a vector of integer type. No, we will create a vector of long type v of size n. Then we will take inputs for this vector. For int I equals to 0, I is less than n, I plus plus. We will be taking input for ith element for the vector. Then we will, after taking our inputs, what we will do, we will now try to find the max sum. So first we will take the initial value for max sum. The initial value for max sum would be vector's 0th element, because in worst case our maximum sum, not in worst case, but our maximum sum couldn't go worse than considering 0 element individually, because even if we are not getting any better sum than by adding elements, then we can consider the 0th element only. So our maximum sum would be initially 0th element. Then we will start from the first element onwards and go till the last element, and we will keep on updating our maximum sum. Now firstly we will check the best subarray sum for this element, till this element. So best subarray sum till this element, how we will get? We will take maximum of either just ith element or the best subarray sum till vi minus 1th element plus this element. So this vi minus 1 is the best subarray sum till I minus 1th element. You can store it in an individual in a different array as well, but in my case I am updating the best subarray sum till I minus 1th element in this vector v only, because we don't need the I minus 1th element anymore, so we can update there only. So vi minus 1 is best subarray sum till I minus 1th element, and vi is the ith element of the vector. So after updating this, one thing, we have to keep it long, the max sum. Then we will update our max sum. Max sum is equals to maximum value of either max sum. If the max sum's current value is better, then we won't update it, else we will update it to best sum till ith element. Then at last we will be printing our max sum. Let's check it for the sample case. Let me copy the sample case. So we are getting output 9. Now let's try to submit this problem. So our solution is accepted. If you still have any doubts or queries, you can ask them in comment section. Otherwise, I will upload next videos very soon. You can wait for that. And for the previous videos from solution number 1 to solution number 7, you can check my playlist. I will add the link for that. I have added the link for that in the description. You can check it from there. Thank you everyone.